Hi, welcome to the Byrne-Wheeler Report. My name is Joe Byrne with XPU.pub.
And I'm Bob Wheeler with WheelersNetwork.com.
We're recording this on the 30th of September, and on today's agenda, we're going to talk about a few product announcements and business combinations that have been announced since our last recording 15 days ago. First up is the Intel-Nvidia deal. Next, we're going to talk about the widely reported Nvidia-Enfabrica tie-up, um, then the Upscale AI launch. I'm going to talk about the new MediaTek and Qualcomm smartphone processors. So first up is the Intel-Nvidia deal. Bob, do you want to recap what the major terms of that are?
Well, it's funny because all anybody cared about was the fact that there was no foundry, Intel foundry as part of the deal, but it was pretty
Yes, I
significant
agree.
from,
Yeah, I agree. I think that's an important thing that it's strictly a product tie-up, and the manufacturing issues are for another day.
yeah, and Lip Bhutan was non-committal on what process the new CPU would use. But fundamentally, there's two pieces to the deal. One is that Intel will develop a CPU with NVLink so that it can
Right,
directly attach to NVIDIA GPUs. And then the second piece is developing PC processors that incorporate NVIDIA GPU chiplets. And so there's both a server slash AI
right.
angle and a PC processor angle.
And I think they actually mentioned NVLink would be used on the PC processor side, but they weren't real specific about the nature of the interface. I mean, NVLink means a few different things, but the thing I noted on I'll just call it the infrastructure or server side, they were clear that the goal was, they talked about how today there are NVIDIA systems that will have an Intel Xeon or pair of Xeons and 8 NVIDIA GPUs that are connected by PCI. PCI is not a great interface, and it's certainly in terms of data rate and latency, and it would certainly peters out at 8, and they talked about getting to NVL72 scale systems using x86.
Yeah, but of course, the interface between the CPU and the GPU is that NVLink C2C that we talked about last time, which
Right.
is a hardware coherent interface. Whereas NVLink on the backplane in the NVL72 rack is not hardware coherent.
So wait, were they clear that there was going to be C2C?
No. But I mean, if they're incorporating NVLink into an Intel CPU, the logical conclusion would be that it would take the place of a Grace or a Vera ARM CPU, right?
Right.
And the whole point is you want your GPU to be able to access the memory on the CPU, which is the major benefit compared to PCIe, aside from just sheer bandwidth, right? Is the
Right.
coherent memory access.
Right.
So I think it's really about um, not locking customers into ARM on the CPU side and giving customers the choice of x86 on the CPU side while preserving the ability for the GPU to access the CPU's memory, right?
Right. I mean, I think the other another issue is, I mean, it's hard to think in terms of competitors to NVIDIA, but AMD is out there with an x86 option that's, relatively well integrated with their GPUs. And in fact, the very first MI300, A version, which is designed for supercomputing, it had a mixture of compute and GPU tiles. So I wonder if they felt like they needed to take this defensive measure as much as it was meeting the needs of customers who preferred x86.
Yeah, I mean, I think for NVIDIA, the challenge here is that to sustain growth, they have to expand beyond the hyperscalers and the neo clouds and
Right.
increasingly sell into enterprise and sovereign AI and all these new markets that they talk about to sustain growth because they can't just keep growing forever based on hyperscaler capex, right? So I think it's for NVIDIA, it's very much like on Spectrum X on the Ethernet side, they did a deal with Cisco, enabling Cisco to support Spectrum X on Silicon One hardware, right? And same deal, it's expanding the reach into enterprise networking where NVIDIA has no presence, basically.
Right. Yeah, and then from a business perspective, the transaction sounds like it's structured as Nvidia's really a system company now. Nvidia's going to buy Xeons, like finished goods from Intel, and incorporate them into systems.
Apparently, that was the way it was positioned, although NVIDIA always says that customers can buy, components if they want components. So not clear exactly how that would work. But since this is more focused on enterprise, I would assume that the channel would be more kind of OEM or NVIDIA systems rather than ODM type systems.
They did say in the call it'll be explicit. Jensen explicitly said we will buy the Intel processors ourselves. On the PC side, he framed it sounded a little more open, whether it would be like a cost plus or it seemed kind of unsettled on the PC chiplet side.
I guess on the PC side, the big question to me is if Intel's selling PC processors with NVIDIA GPUs, where does that leave Intel's Arc line of GPUs? And does that mean that the discrete Arc products are dead from a roadmap perspective?
I mean, whether that's the intent or not, they have to maintain the fiction that everything's alive and because they have this pipeline of a few generations that are going to use the Intel Arc GPUs in the pipeline that haven't been shipped, and it'd be really disruptive if people started fleeing uh, before those went through their life cycle. So I think this is probably time for maybe the follow-on generation products. So 2027 at the earliest, maybe 2028, unless there's an oddball. So on the AMD side, they have this thing called Strix Halo, where on Intel or AMD PC processors, recently they've had monolithic chips for laptops, and then they had these chiplet-based products similar to the Epics that they use in the desktop and some of the high-end laptop SKUs. But this new Strix Halo is a chiplet base and it has a really big GPU in it, so like a discrete class GPU as a chiplet. So it's at this point it doesn't seem like it's taken the world by storm, but this deal could be a stopgap. So before the 2027-28 timeframe, it could be like a one-off product to like occupy that square on the Intel side. I think also on the Intel side, there's been these rumblings of an all E-core PC processor, and Pat Gelsinger, when he was CEO, which was a year ago when this deal started cooking up, said something. He's kind of buying into the accelerated compute story that Jensen talks about. That's the cornerstone of the NVIDIA thesis of like, hey, the CPU is just there to shove data into a GPU. Well, you could have an all E-core CPU with 50 E-cores in this big NVIDIA GPU on a chiplet next door. Like if maybe those two ideas tie together, I mean, kind of makes sense. But it's a lot different from what we have in the PC market today. So just to kind of cap it off, I think on the PC side, it'll probably, like I said, probably be 2027 at the earliest that we see something. Bob, what do you think on the server side before we could see the Xeon?
Given the design cycles, I mean, Not sure, but I would suspect it's a similar time frame. I can't imagine anything coming out any sooner than 2027.
So our next topic is the reported Nvidia-Enfabrica acqui-hire where Nvidia hired the employees and bought the IP associated with Enfabrica and leaving some employees behind. So kind of hiring the core set. Uh, what do you know about this, Bob, and what are your thoughts?
Yeah, well, the deal, although it's been widely reported, hasn't been confirmed, so I don't really know anything about the deal terms that aren't haven't already been reported out there. But I know quite a lot about Infabrica, and just full disclosure, I'm actually under NDA with them because about 2.5 years ago, I wrote a white paper on memory tiering, and this goes back to the discussion about GPUs accessing memory on the CPU. And Infabrica originally launched with this so-called accelerated compute fabric, which was essentially an Ethernet switch on one side and a bunch of PCIe interfaces on the other side. And the idea was it could tie CPUs and GPUs into an Ethernet fabric. Sort of talked about the high-level architecture originally. Then, when they launched the product, they repositioned it as a super NIC. And so it became sort of a multi-host NIC with a whole lot of Ethernet bandwidth on one side and multiple host interfaces on the other side. But what was sort of lost in that rebranding or repositioning was the fact that the real secret sauce in the design was about data movement and about memory tiering. And
Right.
so the ability for GPUs attached to this ACF chip to access CXL attached DRAM. So
Ah,
the PCIe ports could be used to attach CXL memory expanders, which are now available from Astera Labs and others, and attach DRAM through the CXL interfaces to provide a second tier of memory. And then beyond that, the ability to do RDMA over Ethernet and to extend the not the load store domain, but memory accesses across the network using RDMA. And so you sort of had tier one being HBM attached to the GPU, tier two
right.
being DRAM that's CXL attached to your ACF chip, which is local to the GPU. And then tier three is networked memory, where you're actually doing page swaps over RDMA over an Ethernet network. And that was something I hadn't really even been aware of in terms of the page swap functionality. But there was
Okay.
actually some interesting work done at the University of Michigan on something called InfiniSwap, where they did it over InfiniBand rather than Ethernet, but it's RDMA is RDMA. It works over Rocky as well as it works over InfiniBand. And they showed how you could do page swapping over the network. And so if you're doing something like migrating a VM or migrating a workload or doing other kinds of page swaps, RDMA is actually better than load store where you're doing typically much smaller transactions, right?
Instead of
Um,
doing like 64 bits at a time, you're doing,
Yeah, and so
updates of
doing
memory at a
sort of
time.
split scale transactions. So anyway, that's really the core of what Infabrica was doing was around kind of memory disaggregation and memory tiering, and that kind of got lost in the SuperNIC positioning. But my sense is that that's probably what's of great interest to NVIDIA. And going back a couple of years ago, Infabrica started talking about the importance of this to AI inference in particular. And so, as NVIDIA is looking more towards developing inference optimized systems, this, whether it's the IP or the or just the know-how of the team, however it gets integrated, probably fits very nicely into the work they're doing around inference optimized AI systems.
So, in terms of this CXL memory, do GPUs today know how to address CXL memory?
No, none of the GPUs have CXL interfaces today. Supposedly, it was on AMD's roadmap at one point, but never. appeared, and instead, the GPUs are just accessing DRAM through the CPUs. And I mean, kind of the joke about Grace was it's just a glorified memory controller, right?
Yeah, it's the
It's
world's biggest DMA engine.
yeah, it's a memory controller with some ARM cores attached, which is obviously
Yeah.
not the case. But the point being that a large part of its function was really just memory expansion for the GPU. So this offers a way to do memory expansion through CXL expanders rather than through a CPU, and it gives you a lot more fungible kind of architecture in terms of the ratios of DRAM to GPUs. And the kind of the problem with the NVL 72 approach, or the so-called super chip, is that you basically have two GPUs per CPU is the standard, right? And what if you want more or less DRAM per GPU with bandwidth and scale?
Right.
And so it doesn't scale up and down very easily because you're tying the GPU to a fixed number of CPUs.
And the other thing is this, by aggregating multiple GPUs or multiple CPUs together, you've kind of disaggregated memory, like CPU computing and GPU computing, and you can sort of scale them however you want, and you have this nice share pool of memory. So it seems like it provides a lot of flexibility because, I look at the big data center GPUs today, they rely on HBM, and then if your working set's not there, you have to spend a lot of effort shuttling it over a link from a CPU. And so it's pretty far and onerous. So we could see something in a few years that could be pretty interesting.
The last thing I would add here is, and this kind of caught me by surprise when they announced it, but at the end of July, Fabrica actually announced a memory appliance. And so it kind of brought them
Oh
back
God, that
to,
sounds like a peak CXL thing. Is
yeah,
is
exactly.
a memory
Kind of
appliance thing.
called emphasis, not the way the word is spelled, but anyway, they launched this at the end of July, and it did kind of bring them back to this whole point about memory disaggregation and scalability. And you would have to assume that some sort of deal was in the works by that point. So it's not clear why they went ahead and announced a system level product. But it did kind of bring them full circle back to this whole message about memory disaggregation.
And maybe it ties back with our discussion on our last episode about the RTX-like products that are complementing the big fat GPU and splitting the inference workload between two types of GPUs. It seems like there's some interesting thoughts afoot about how to redo system configurations.
Yeah, I think NVIDIA's story has been it's a one size fits all kind of. The NVL 72 works for everything, and but in reality, customers want more systems that are more optimized for a particular workload.
Right. Okay, next up was the Upscale AI launch, and Bob, I thought they were making crypto chips for a while. And a year ago, I said, "Hey, I saw this story on the web about how the people at Auradine were doing something other than crypto chips, and now we have Upscale." So tell us about Upscale and what's going on.
Yeah, so it was a little, the spin out was a little bit of a surprise. It had been kind of discussed that Oradine was looking at the scale up switching space. And as you said, Oradine was the crypto mining ASIC company.
But
And
but the key people from Auradine, what did they do before they started crypto mining?
well, so I guess Upscale AI's, I think, executive chairman is his title now, is Rajiv Khamenei, who you'll remember from Cavium, as well as he was also founder at Innovium.
Right,
Um,
which was making Ethernet switches.
correct. And CEO, Barun Carr. He came from Palo Alto Networks, so he comes from a little different background, but Juniper, I think, before that.
So basically networking-ish guys.
Guys with networking credentials for sure. And so a few months ago, they spun out this Upscale AI as a separate team with about 100 people. Um, and then announced the funding, which I think was 100 million in funding um, for the spin out. And the announcement sort of have three different points in it. And what's interesting is, as had been discussed, they're developing scale up switch silicon as had been previously discussed for Auradine. But more imminently, they're actually going to be launching a scale out solution,
Hmm.
a system level product based on third party silicon. So,
Really?
yeah, so they plan to have a complete scale up and scale out uh, offering. And to get to market quickly on the out side, they'll use third party silicon. Given the Innovium history, one might guess that it's Marvell switch silicon that they'll be using for the scale
Because
out
Marvell
solution
acquired Innovium.
because Marvell acquired Innovium, correct?
Okay, so this could be interesting. And by scale up, we're really talking about Ultra Ethernet,
No, by scale up, we're talking about UA link, actually.
UA link.
Yeah.
Okay,
So we would presume that this will be UA link switch silicon, which would be competing with Astera Labs. And I mean, interestingly, Marvell as well, although Marvell is only approaching the market from a custom perspective. They haven't said that they intend to do standard products for UA Link.
well, what about UA link over Ethernet, like we talked about with Broadcom last
UA
episode?
Link over Ethernet isn't a standard, right? It's basically just tunneling something
Yeah, yeah,
over Ethernet, and yeah, so scale up Ethernet, as Broadcom calls it, will be there in the meantime. And I guess, the big concern about UA Link is what if turns out that scale up Ethernet is kind of good enough?
right.
Does that then obviate the need for UA Link? And um, the other factor is that the customers here are mostly doing their own custom accelerators. And so you can imagine not every custom switch is going to be the same and not necessarily interoperable with other UA link switches. You could have one flavor that's based on PCIe physical layer, PCIe Gen 7 physical layer, and another one that's based on Ethernet physical layer. And the market's likely to be a little bit fragmented.
Right. Okay, which is kind of unfortunate, but from a standard products perspective, but customization for the hyperscalers seems to be the new big business model.
It's certainly Marvell's story. I mean,
Yeah.
they're virtually not doing standard products for the data center anymore, with the exception of their Ethernet switches.
I mean, I can see the appeal because basically you're lining up the customer and the commitment before you commit to some expensive R&D.
Yeah, I mean, you have to commit to doing the IP in advance of customer commitments, but you don't have to tape out a product, right? That's the difference. I mean, I think the previous management at Marvell, going back, I guess it's 10 years now or so, um, that would be more design win driven, but that's dangerous because then you're always behind the curve on technology development. And so this team is a lot more forward looking on technology development, but then from a go to market standpoint, doing essentially custom products.
I mean, I think it fits in with the general conservatism amongst most semiconductor companies these days.
I mean, if you can, in a sense, it's conservative. On the other hand, they're doing 3 nanometer test chips and working on 2 nanometer now. And I mean, they're
Yeah, yeah.
spending tens of millions of dollars a year just on SerDes development, right?
Right.
So I mean, they are investing substantially in IP, and then they're able to spin these custom products much quicker when once they have a customer
Right, but they
commitment.
minimize the risk of a goose egg product. It's something that you had the handshake deal and then you finish it and the customer kind of goes away and
Absolutely,
waits.
and there
So,
are always NREs involved to help with the
right.
upfront costs as well.
I wanted to move on to the smartphone market. And so the two big merchant suppliers, MediaTek and Qualcomm, just introduced their new products. Uh, the mainly I wanted to actually focus on the CPUs here, and the reason is there has been, there's going to be crossover from the CPUs used in smartphones as they'll be also used in PCs as well as server chips. So historically, ARM had Cortex and Neoverse. They renamed the Cortex for smartphones, are now called Lumix, but the microarchitectures are shared between the infrastructure-oriented Neoverse and the smartphone-oriented Lumix, but they'll add some RAS features or increase the number of physical bits of memory address space you have, things like that. So on the MediaTek side, they're using the ARM Lumix CPUs that we talked about last episode that are available in 4 tiers, with the Ultra being the replacement for the Cortex X series and being a very wide execution machine. And they've bumped the clock rate up significantly. So in MediaTek's case, it's now running at 4.2 gigahertz in a smartphone. But Qualcomm tops it. They acquired Nuvia several years ago, and they now have their own homegrown ARM compatible, and that thing runs at 4.6 gigahertz in the smartphone product, and that gives them some very, very high peak performance figures. And I think the crossover is at the same time they discuss their new Snapdragon X Elite series for PCs. It's going to use the same microarchitecture, but they can run it at 5 gigahertz. So we now have 5 gigahertz ARM compatible processors entering the market. So from a clock rate perspective, that's a big number. They don't have the instruction throughput of the ARM processors that Apple developed, um, but because the clock rate's so much higher, these should be the fastest ARM processors in market, and they're from a laptop perspective, where the x86 guys downclock so much, um, they're going to beat x86 on key benchmarks. So I think we're seeing a lot of competition on the ARM side, that's resulting in a push to higher and higher performance, and it's starting to overtake x86, which I think is a prerequisite for greater adoption of ARM in PCs, and then maybe eventually, possibly merchant servers, although they're doing reasonably well on the homegrown hyperscaler processors. Do you have any questions about this, Bob?
Yeah, I guess on the PC side, I mean, clearly, Apple started the whole migration to ARM on the Mac side,
Yeah.
and I think that caused the PC OEMs to look for ARM-based alternatives and probably enabled the market for products like Snapdragon X, right?
Yeah, I think so. And then meanwhile, it's been, what's 2025 now? It's been about 10 years of, let's just call it iffy execution on Intel's part. So it made sense for the PC OEMs to start looking for alternatives. And it seems like Microsoft itself was keen to be less attached at the hip to Intel as well. So I think a few factors have come into play to heighten the interest. They're not, if you look at market share figures for PCs, ARM looks pretty good, but a lot of that's Chromebooks where till now Chromebooks haven't been, let's say, leading edge technology by any stretch. But I think that could change
Yeah. I guess
on the Chromebook side. Yeah.
on the server side, I mean, I think the question remains um, with the hyperscalers so dominating the space
Yeah.
and having their own custom AWS having Graviton and Google having their own ARM processor, Microsoft having their own ARM processor. But is there enough of a market for a merchant ARM server CPU? And remind me what happened to Ampere.
um, at this point, I don't recall what has happened by. Oh, they were acquired by SoftBank. Yeah, so they've been absorbed there, as well as GraphCore, which was, an AI chip company, and they still own a big chunk of ARM. So there could be something there, but there really is no existence proof of an ARM-based merchant server processor, and in fact, there are several counter examples.
Yeah.
And I
The
think
other
also
one
if we
is,
go ahead.
yeah, the Marvell Thunder X would be the other example.
ThunderX would be another one. Calzetta, you know, Ampere for a generation they licensed ARM cores. They had reasonable traction. Reasonable meaning like they got some pilot deployments and they had a nice essentially a development workstation that was ARM compatible, which is something the ARM community could really benefit from, but hasn't really gone anywhere. Part of it is they just haven't gotten the right mix of CPU performance and configuration. But I think also we go back to the discussion at the top of this episode, the Intel-Nvidia deal. I remember, Bob, many years ago we were working on storage processors, and there's some really neat technology. And then every enterprise is like, look, man, this is storage. Like, we'll stick with the thing that might not be good enough because we know it works. And I just feel like enterprises are like, we know the x86 works. You're talking about these benefits that are pretty marginal, and so they really don't have a big incentive to switch.
Agreed. And that kind of circles back to our discussion about the Intel Nvidia deal, right? And why Nvidia would
Yeah.
want an x86 CPU in their platforms. So interesting. The first episode was mostly about products and technology, and it seems this episode was more business focused, a lot of deals popping up. So activity continues, and we'll see what next couple weeks bring. Joe?
Right. It'll be, it's always a surprise. So yeah, I would say for everybody, thanks for tuning in. You'll see us in our next episode. And for more information, please go to xp.pub and wheelersnetwork.com. If you found this video interesting, please help us out by spreading the word. Just tell 4 friends, send them a link. And if you have questions or comments, you can put them below. And until next time, be well.
It's all about the opinions, baby.